Let us now study what is fractional distillation. This technique is used when we want to separate a mixture of two or more miscible liquids whose difference in the boiling point is less than 25 Kelvin. This example, we will study example of this in detail in the next slide, where we are going to study separation of different gases from air through fractional distillation. This fractional distillation apparatus is similar to a distillation apparatus. If you remember, it's got a distillation flask, a condenser tube and a beaker, and then we heat the solutions. Just that it will have one more additional apparatus called as fractionating column. A simple fractionating column, it is a tube, it is a glass tube which is packed with glass beads. Okay, the beads provide surface for the vapors to cool and condense constantly or repeatedly. Where is this technique used? It's used in petroleum products, in separation of gases in the air, and in pharmaceutical industries. The two links, please watch the videos that are given on those links to understand fractional distillation better. Let us try to understand how fractional distillation is helpful when we want to obtain various types of gases from air. Air is a homogeneous mixture and it can be separated into its components using fractional distillation. Now, what exactly happens in fractional distillation is the components of the air, say for example over here oxygen, nitrogen, argon, they have different boiling points. So we are going to use this method to segregate these components based on their boiling points. For that, we have to separate the gases. Before it, we need to compress the air and then cool that air, compress that air and then cool that air by increasing pressure and decreasing temperature. So compression will increase pressure and cooling will ensure that the temperature drops down, because of which this air gets converted into liquid air. This liquid air is then allowed to allowed to warm up through the fractionating column. Now this process really occurs very slowly, and it is at this stage that the gases start separating out and depending upon their boiling points, and thus we can collect them differently. Understanding physical and chemical change. Now this is a recap of what you have studied in the previous standards. Also in the previous lesson we discussed few physical properties of matter, like something that can be observed or in terms of color, hardness, densities, their melting point, their boiling points. These are all physical properties. However, when there is an interconversion of states, um, where a no new substance is formed, that can also be categorized as a physical change. Whereas when the interconversion doesn't happen, rather it gives rise to a new substance, we say that that change is a chemical change. Okay. Now, what do you think is burning of a candle? Is it a chemical change or a physical change? Before you answer that question, just go through the table given on the slide carefully. This brings us to the end of this lesson. Is matter around us pure? So far, in the past two modules, we have seen how matter is classified. We have understood what are mixtures, their types, solutions, their types, how to calculate concentration of a solution, and then we also talked about various separation techniques if you want to separate mixture. Now there's a link given in the slide. Please refer that, watch that video. It will help you to visualize the entire lesson. Also try and complete your textbook exercises along with all the in-text questions pertaining to this lesson.